Oh, yes. Right.
God, I can't see anything.
Welcome back, everyone who was here yesterday. Thank you for coming back, indulging us. We've just been having some drinks, so we're a little excited. And so firstly, just to thank our sponsors, the McKinnon Family Foundation, of course, the Santa Fe Reporter. That is so bright.
Is there any way to turn it down a bit?
And yes, because you're not standing, the angle. And the Lensic Performing Arts Center, because it's always so wonderful to be here. And I'm going to introduce my 4 co-conspirators. Melanie Mitchell, professor at the Santa Fe Institute. Melanie's research focuses on abstraction, analogy making, and visual recognition in AI systems, among many other things I might add. Sarah, to my right, is a professor at ASU, Arizona State University, an external professor at the Santa Fe Institute, an astrobiologist and theoretical physicist who gave a talk here not that long ago, with research interests in the origin of life, astrobiology, the physics of life, and emergence. Talia, at the end there, is also an external professor at the Santa Fe Institute, professor of and that is that she adopts the accent of whomever is speaking before her.
That's not whomever. Sorry. Okay. This is my worst nightmare because I grew up in England. Went to for those of you that were here last night, my parents took me to Downs House when I was 10. I'm fully English. I have a passport. But at the age of 12, I moved to the States. And I was ostracized at school for, you talk funny. I moved to Texas. And so I had to kind of create a kind of Americanish accent based on what I heard from the Waltons, Dukes of Hazzard, an aggregation of the things that I was exposed to. But I would use this at school, but then my parents wouldn't allow me to speak it at home because it was an affectation. So for many years, I had to speak one accent, the American accent, from 9 to 3 in the weekdays, and then my English accent at night. Anyway, it has firmly established that I have 2 separate accents. And whenever I'm in the context of a Brit, I speak with my original English accent. And when I'm in the context of American, I speak with my American accent, and I'm not able to control this. And so I live in fear of a dinner party or whatever where there's a mixture of Brits and Americans because I will appear insane. And this is even worse than that, right? Because there's all of you observing this and not knowing what's going on. So just in case my accent wanders around, I wanted to explain that. Thank you.
There you go. So, yes. So, okay. So, what I would like to do is allow each of the panelists to briefly communicate to you their interests. And I'm just going to cue them up, just all together, concatenated, to give you a sense. So, Sarah's great work on extending physics, principles of physics, to living systems. Jeffrey's use of physics principles to explore adaptive systems and the limits of those principles when it comes to looking at socio-technological systems. Talia, your work on the nature of interactions and social behavior. And Melanie, your interest in intelligence, both in machines and the rather unique ability maybe of humans to form analogies. So, Charlie, let's start with you. Just a brief review of your interests.
Right. I'm interested in how we connect to each other, both in our social networks, but also how we have conversations with each other and why we fall in love with some people and not others, why we connect with some people and not others, feel like we're clicking with some people and not others, and why we spend so much of our time in interaction with each other, in conversation with each other, and how conversation works. So most of my work right now is in this amazing technology that I think really changed our species, which is that we talk to each other all the time, and that sculpts our neural networks. So I hope at some point to talk about these amazing emergent patterns that we create whenever we get in interaction with each other and talk to each other and create new patterns that couldn't have existed in my brain or your brain, but somehow when we put our brains together, we create this amazing, emergent, innovative stuff. And that's magical, and I want to understand it better.
Not bad, not bad. We're going to try and do some of that for you this evening. And Jeffrey.
Oh, okay. So as David said, I'm a physicist, and I see the world primarily as a physicist, which means I'm interested in the big picture, the principles that transcend the diversity of life rather than the diversity of life itself. And I'm shamelessly a physicist in the sense that I think the achievements of physics are truly one of the great achievements of the human mind. That is the deep understanding of the fundamental particles, the fundamental principles that control the world around us, and equally importantly, the universe. We have a credible theory for the origins of the universe, the evolution of the universe, the formation of galaxies, the formation of planets, and so forth. And one of the things you learn from all that is that the most interesting place in the universe is here. And so one of the big questions is, and that's what I'm really interested in, how can you take that framework, this extraordinarily powerful framework that has been so successful, and apply it down to and ask about universal principles of life. And part of life meaning not just biological life, but socioeconomic life. And the thing that I'm most passionately interested in is truly the question whether the extraordinary success of socioeconomic life that has brought us to all the marvelous things we are privileged to participate in, is it even in principle sustainable? And so that is a very deep and difficult question, but I think physics and thinking through a physical lens is a fantastically powerful place to begin, and then integrate, and that's what Santa Fe Institute is about, really, the other sciences as one tries to understand what is the dynamic that we're involved in and where is it leading us.
All right. Sarah.
Yeah. So like Jeff, I'm very interested in universal principles of life, but I think I've been obsessed most of my career with the problem of the origin of life, so how non-living things transition to living things. And I was trained in theoretical physics, and I absolutely love the beauty of the deep explanations that we've uncovered in the history of our species, but I think we're not done yet. And so one of the things that I've really found thinking about the problem of life and how life arises in the universe and whether there's possibilities for alien life is that the fundamental explanations that we have about how reality works might be very different than what we've told ourselves in the past. And I'm really interested both in the science, like how to actually do better experiments and test ideas about theories in this area, but also the kind of explanations we create as a species and how they carry us into the future. And I think both those things need to work together. So I guess in summary, I really just want to know what we are and how we solve that problem, how things like us emerge in the universe, and then what do we do with that knowledge?
I should say, just a shameless plug,
is
Sarah's new book is out. Here it is, Life as No One Knows It. You should all go and buy it immediately. Okay. Melanie.
Yeah, so like many at the Santa Fe Institute, I don't fit into a single pigeonhole of academic discipline. I'm a computer scientist and a cognitive scientist, and I'm interested in how people's intelligence works and how we can get machines to be more intelligent. And that often requires trying to think about what actually is intelligence and how our ideas about it have changed over the years. Back in the 1970s, when AI was still quite young, a lot of people thought that if we could only get a computer to play chess at a grandmaster level, that would encompass all of human intelligence, all of the brilliance and the, because it's a high intellectual achievement to be the world champion at chess. But then, of course, came along IBM's Deep Blue program, which beat Garry Kasparov, and was not intelligent. No one would have claimed that it had any kind of general human-like intelligence. It was really using the brute force of computation. And after that, there have been many different milestones in the history of AI that have continually challenged our notion of what intelligence is. And now today we're facing things like ChatGPT, which can converse with us in very human-like way, in very fluent language, and we're saying, is this intelligent? Is this what we mean by AI? Or is there still something missing about its intelligence? And that's the kind of thing that I'm looking at and trying to understand in my research.
Fantastic. By the way, behind us, it's a loop of figures, ideas, machines that have played some role in the history of complexity science. We can't see them, but I'm sort of tantalized by them. So if occasionally we look around, that's why we're looking around, but that's what they are. They're there really, if you get a little fatigued with us, you can look at the screen. Okay, and by the way, you can all, I'm just an enzyme. And so you can all ask each other questions.
You're actually a sausage.
For those, he doesn't realize I'm going to take my revenge on him later. Okay, so let's just start with this other question, which is inspiration. Science can seem rather forbidding and dry, but of course it's not. And like everything else, there are books or ideas or people who've inspired us that led us to pursue this path. And I want you to ask each of the panelists who that might be, what this idea is, what that book was, and maybe in two parts. One in the realm of, I guess, what we would call, non-fiction, and also with novels and works of art. So I wouldn't restrict yourself to that. So anyone can start who feels inspired. I'll pick you. Okay, I'm going to look at Sarah, you go first.
Oh, excellent. When I first thought about this question, I thought about something different, but now I have a different idea in my mind. But I did not like science as a child. It's not that I didn't like it, I was really curious, but it just wasn't on my radar as something of interest to me. So I went to community college because my parents didn't attend university, and they were both very artistic, and I thought I was going to be an artist, but I took physics, and I absolutely loved it. And I remember the exact moment, actually, that I fell in love with physics. And it was when my professor in my physics class in community college was talking about magnetic monopoles. And for people that don't know, a magnet has a north and south pole, and if you cut it in half, it still has a north and south pole. But physicists have conjectured, as we like to do, that there might be isolated north or south poles in the universe, and we could go and look for them. And so this was actually the idea that I fell in love with, was the fact that the human mind could build abstractions about nature, and we might actually be able to go out in the universe and look for whether they're real. And so I think that's why I decided to become a theoretical physicist, because I thought the correspondence between how our minds construct ideas about reality and what's really out there was really profound and worth spending my life on. So I vividly remember going home and being to my mom like, I don't need my 17 magazines anymore. I'm going to read these like modern physics textbooks. And which was kind of funny. But that was it. So that was a pivotal moment for me. I don't know. I'll let you guys go.
I love that. I've never heard anyone be inspired by the idea of magnetic monopoles.
I know, it's kind of silly, right? Yeah,
that's brilliant. It was brilliant. And Jeffrey.
Well, let's see. I think the idea that inspired me and somehow guided me into becoming a scientist, and in particular a physicist, was a homework problem that was given when I was taking a trigonometry course about maybe age 11 or 12, I don't remember. And it was a very simple problem. And that was that how far away is the horizon? And I lived at that time on the coast in southern England, where, you know, those big white cliffs that you see, White Cliffs of Dover. And one of the things I was intrigued by, of course, was watching the ships go down below the horizon. So that sort of intrigued me. But what was amazing to me was that I could actually do the simple trigonometry, basically Pythagoras' theorem, and you had this little formula that told you how far away the horizon was, depending upon how high you are up on the cliff or on a building, and it involved, obviously, the radius of the Earth. And here was this formula that was extraordinary because it could predict something quantitatively that was out there in reality. And at some semi-conscious level, I also realized that if I were on Mars, it would also tell me how far the horizon was, but it would be a different answer because it would depend on the size of Mars. And the reason it inspired me was because I had come from a religious family, and all the explanations there were relative to that were so qualitative and so bullshitty that suddenly here was something that was so precise and so extraordinary, and it involved something grand, namely, you know, the size of the Earth. And I think that sort of stuck with me and inspired me to, you know, this is the way to truth and to understanding. So that's one thing that inspired me. The other thing that inspired me was reading Victorian novels, especially Thomas Hardy, because Thomas Hardy talked about relationship. And in particular, the one that did inspire me was, this is much later than 11 or 12 years old, this is more like 18 or 19, is Jude the Obscure, and the story of a young man who is extremely intelligent but has no way of expressing it, and has this extraordinary, deep, passionate relationship with a woman. And that also inspired me when I realized that there were only two things that mattered in life. One was deep understanding, and the other was love. And I try to keep, that's how I try to live my life, and that's what inspires me to be at the Santa Fe Institute, because it is a place that
makes life hard for the rest of us. I mean, that second part in particular, but there you go. Melanie.
So when I was in high school, I got very obsessed with logic puzzles. I had a book of logic puzzles, actually. It was written by a mathematician named Ray Smulyan, who probably some of you know. And they had, the puzzles were things like, there's the knights who always tell the truth and the knaves who always lie. And you don't know which one is which, and you have to figure out the question to ask that will tell you for sure which one is which. And it was full of questions like that. And then, so I got really obsessed with logic and understanding logic puzzles. And then I went to college, I studied mathematics, and found about Gödel's theorem, which is the ultimate kind of logic puzzle. It tells you sort of what things in mathematics can be proved and what things can't, and why there are things that can't be proved. And it was so exciting to me. But at that point, I didn't really know what I wanted to do. And I saw in a bookstore a book. I was very, interested in Gödel's theorem and that kind of thing. I saw this book with this very strange title. It was called Gödel, Escher, Bach. Mm-hmm. Some of you have seen this book, or some of you might have read it. And it was by Douglas Hofstadter, a physicist who had decided to write about his passions about...
Who, by the way, was a student of mine.
Yeah, I never knew that, but made that connection. But he had decided to write a book trying to bring out his passions of music, art, and mathematics, and how he thought they all were deeply related, and what they were related to was the emergence of the mind and what basically intelligence is. And so that book really inspired me to go into AI. It inspired me so much that I sought out the author, Douglas Hofstadter, and volunteered to work in his group, and ultimately became his graduate student and got my PhD with him as my advisor. So that was very exciting. But David also asked us about a fiction book. So I'll go even further back in my childhood when I read the book A Wrinkle in Time, which is a fantastic book at any age. But what it really inspired me because it was about really big ideas about the universe, but it was also the main character was a girl. And it made me realize that actually girls can do this kind of thing. And that was really a revelation at the time, but I think was very inspirational.
It's interesting, just as a side note, for many of us at SFI, Gödel Escherbach was the book that got us interested in complexity. I think it's if you haven't looked at it or read it, it's still a masterpiece, I think, to this day. China.
Well, there's so many ways to answer this question, but going back to something Jeffrey said, I used to be, this is a series of overshares, I used to be a fundamentalist Christian back in sort of between my teenage years and early 20s, until I read a book by a psychologist, Tom Gilovich, and the title is How We Know What Isn't So. And it's essentially a book about how do you evaluate evidence and claims, and how do you, and the hidden data problem. So if someone says, well, you know, I was cured from cancer, that's praise be to God. What do you think about the cases of cancer that weren't cured? Or, you know, like you have to look at all the different sort of cells to evaluate whether it was God's plan or not, and things like that. And as a fundamentalist, this sort of was very, it sort of shook my faith in a way. And I had to sort of grapple with how do I evaluate data and make conclusions about it, and it ended up actually, and if you're a believer, that's fantastic, whatever. But this, for me, ended up really shaking my faith to the core and abandoning that, at least that strain of faith, and which I was also married at the time to a fundamentalist Christian. So this was actually a very fundamental book for my personal growth, right? And I became a scientist. And so that was sort of a book I still think of as being a turning point for me. In terms of being sort of more inspirational in a more sort of maybe positive way, I think this is not a book, although I have those, but when I was in graduate school, my graduate advisor, rest in peace, he died a few years ago, I was struggling with trying to figure out, well, what kind of question should I be asking in science, and like what do people not know? And he sort of threw up his hands and he said, just go out in the world and observe, just live for 30 minutes and keep asking, why is it this way? Why is it this way? Why is it this way? And within 30 seconds, you'll figure out something that we don't understand. And go and understand, like, why does music move us? You know, why are dolls creepy? Why why do we click with some people and not others? You know, like all of these major questions. Why do we fall in love with some people and not? These are deep questions, and we don't have any answers for them. And so, as a budding scientist, it made it clear to me that the world is absolutely wide open to explore these questions.
Thank you. I have to add one myself, because yesterday, for those who were here, Jeffrey pointed out that one of my favorite novels was Moby Dick. And he said, how could that possibly be the case? Because it's a book that only has men in it, no women, so consequently probably is not about love. And so I want to say two things about that. First of all, Jeffrey, in case you didn't know, Herman Melville was gay. And one of the most beautiful and sensitive love scenes in literature is the early scene between Ishmael and Queequeg, for those who don't remember. So that's the first point. Second point relates to our dear departed friend, Cormac McCarthy. So Moby Dick was also his favorite novel. And I remember being at dinner with Cormac and my brother, John. And Cormac asked John, do you love Moby Dick? If you didn't, by the way, you weren't entitled to sit with him to dinner. And John said, yes, I do, but I prefer Marcel Proust. And Cormac said, you don't love Melville enough. So anyway, so that's Cormac on Melville. So let's move this a little bit more towards science, and maybe towards what sometimes is called meta-science, which is, and this in relation to complexity science, what slows it down? To use a more technical term, what is rate limiting in the progress of science? And is complexity science like physics, where we need new telescopes and particle colliders because the technology somehow is integral to progress in the field? Or is complexity science more like mathematics, where it's not the technology per se, it's the ideas and the frameworks? And I'd like to hear from all of you, both in terms of your own experience of research, but also maybe commenting on the field as a whole, what you think slows down the progress of science. Maybe Melanie, I'll start with you.
Well, that's a broad question. In my own field of computer science and cognitive science, I think right now the real limit is in coming up with a framework that will help us understand what intelligence is. And we have neuroscience, the brain, right? Intelligence is, we think of it as associated with thinking in the brain, and neuroscience has all kinds of instruments and scanners and electrodes that can be stuck into neurons and measure all kinds of things. But what they don't have is a good theory. They're missing some larger conceptual framework for making sense of this incredibly complex system of the neurons in the brain also interacting, of course, with the body. And that's, I think, also lacking in artificial intelligence, is a framework, instead of just kind of like what I mentioned with Deep Blue, throwing computing power at these systems, and computing power has gotten very, very powerful in the last couple of decades. What we don't have is a real conceptual theory to guide us into understanding and creating this very ill-understood phenomenon. And Jeffrey, I think a few years ago, he wrote this wonderful essay called "Big Data Needs Big Theory." And what people are doing in my field now is really focused around big data. Let's train all kinds of neural networks on all kinds of data, everything we have in the entire digital world. And we get all kinds of behavior that seems really interesting and counterintuitive, but we're lacking a theory. So for me, to say, is it more like physics, where physics really didn't progress until there were theories to make sense of all the data that was being collected by the telescopes and the microscopes and so on. And I think that's really what we need in complex systems, particularly in my field as well.
Can I jump in there? Because I think I may switch to American now. I think my answer is related to yours, in the sense that we think about the brain, neuroscience, as being this very sort of heady science of understanding neurons and networks in someone's brain. And it's been a science of the brain for over 100 years. But we actually do our thinking with each other most of the time. and we leverage each other's brains. We get together and ping pong ideas, use each other as sounding boards. We generate ideas we couldn't have gotten to alone with each other. And that massively networked enterprise of our intelligence, we don't understand either in neuroscience or in artificial intelligence. Because neuroscience has been really for its entire history about mapping the isolated brain, as if we, evolved in jars or something, our brains in jars. But we didn't. We're massively social. And neuroscience is just now starting to try to figure out what are these patterns that we create with each other's brains? How do our brains work? Because we're like Lego blocks, right? The whole point is to put us together and create new things. That's the foundation of culture. That's how we get all of this off the ground, is talking to each other and cooperating and making alliances and innovating. And right now, neuroscience is the science of the individual brain. And I think for me, that's the rate limiting thing. And I think we won't get to a kind of an artificial intelligence that approximates human intelligence unless we kind of understand this leveraged social network sort of intelligence that really is how we think.
Can I just, sorry, I just want to just quickly though, Tony, it might be worth, and yet, knowing your work, neuroscience is partly the science of individual brains because of the giant squid axon, right? Because of putting electrodes into single cells, and that's something that we've had for decades. You, in your work, are doing these very interesting people communicating each in fMRI scanners.
Yes.
So can you just talk about that briefly? Because that is a case where, to answer your question about the networked intelligence, you might have needed that kind of technology. Is that true? Or is
Yes. So, I mean, one of the reasons why historically we haven't been studying brains and interaction is because we haven't had the tools to do it. But that's changing. And so one thing I do is I have people in brain scanners that are talking to each other and creating, like telling. So one of the paradigms I use, for example, is that imagine you're in a scanner and someone else is in a scanner, and you can hear each other and you can talk to each other. And I give you both a prompt, like a kid gets into trouble and I say, okay, you start making up a story. A kid gets into trouble. And so you start talking about this kid whose name's Billy and runs across a stray dog on his way to school. And after 30 seconds, you have to stop talking. And your partner has to pick up where you left off. And they talk for 30 seconds, and then it goes back to you. And you create this sort of fantastical story. And what we're seeing is that these beautiful emergent patterns are created when two brains come together to create something new that didn't exist before. And the patterns are not reducible to just adding up this person's brain activity plus this person's brain activity. It's something completely different that we're creating when we talk to each other and we create new ideas. And that's what I'm interested in, and we're just at the beginnings of understanding this, but I think it's really important to understand these kinds of processes because they then, can tell us about how ideas transmit in networks and change people's minds in large-scale sort of societies.
Sorry, Sarah, you wanted to jump in.
Yeah, no, I think I was really inspired by something Melanie said and also something Talia said, which is, so I work in the origin of life, and it's kind of similar to the field of intelligence and thinking about AI in the sense that we don't have a paradigm and we don't have a conceptual framework. And I found what really frustrated me in my field is that many people in the field actually think the problem is not solvable, and they operate from the perspective that's not solvable. And I don't know if this, I wanted to ask if this was true in your field, because people say there's a general problem with intelligence, but people don't actually sit down and say, what do we mean by this, and like really focus on the fundamental problem. Yeah. And so maybe you can speak to that for your field, because that was part of my question. But then when I heard your response to that, it was exactly what I think you need to do, which is if there's a fundamental problem we don't know how to solve, we have to believe it's solvable, but we might need to ask a different question. So instead of looking at a single mind, maybe you look at multiple minds, right? And that's the better way of answering it. So I think I was I was really resonating with sort of the juxtaposition of the 2 points there. And then I guess for me, I was also emotionally resonating with actually the point that you finally made about minds having to connect to make new ideas and the way that this actually operates when you interact with different individuals. Because for me, science is very emotional. It's not like I know we're supposed to come up with objective ideas, but it's very intuitive and it's very cultural. And it's very collective. And so I see the way of sort of constructing new theories and new understanding, trying to recognize there are problems, but they are solvable. And that the transition of doing that is really trying to understand what questions we actually are asking, which may not be the questions that we think we're asking. Yeah, so I guess I had a question for you, and then I don't know where that goes, but yeah. Maybe.
Yeah, I mean, in AI, all of the big companies, you know, Google, Meta, OpenAI, Amazon, they all have the goal of creating what they call AGI, Artificial General Intelligence. And it's very ill-defined. It's kind of like, well, no, it's like the AI we see in the movies. And there's very little sense of having to scientifically investigate what that is. But what the way they envision it is an individual brain-like thing that's disembodied, asocial, not sort of separated from the world, and very different from anything we've ever seen in biological intelligence. And the question is this even a reasonable goal?
Well, it's not a question. That's what intrigues me about it. So I think the thing I find with most like deep thinkers is they have a question and they're obsessed with that question. And I think like we heard that at the beginning, but this is not how you're describing your field. They don't have a question. They're not like trying to solve a problem.
They have a target.
They have something they want to build that's
the
magic.
target is not, it's sort of fuzzy out there.
They have a market.
Yes,
Yes,
they have a market.
Different idea.
Different than a question.
Jeffrey, on that.
Just one comment on that,
Yeah.
and that is that I was going to say also, it's driven, of course, AI is to some extent now, maybe to a great extent, is driven by market forces and making money and so on. But also, I think the field is dominated to some extent, again, by engineering thinking, which is good in the sense it's trying to solve a problem, but it means that the conceptual framework plays at best second fiddle, and I think that's part of the problem. So going to your question, I have a very similar response to Melanie's, in that science, the way science is done in the fields I've worked in, either the physical sciences, social or biological sciences, especially the social and biological sciences, it sort of breaks down into three different categories. There's a huge amount of work done on very specific problems. The sewage system in Dallas, or some very specific plant, or some very specific tumor. That's enormous, and this is crucial for science, but it tends to be dominated by that. Then there's a whole other bunch of investigations which are related to that and driven by computation, and that is, sort of trying to simulate it computationally, and almost having, a one-to-one correspondence, a useless map of what the problem is. And then there's the other end of the spectrum, which is sort of trying to make a big picture, conceptual framework, which often ignores many of the details and important experiments and so forth. And so that's sort of a cartoon version. And what is hindering progress, in answer to your question, is that outside of physics, none of these are integrated. Physics has been successful to a large degree because all those processes are going on together. They respect each other. They want to interact with each other. But one of the disturbing things I have discovered working in biology and in the social sciences is that people with these very different or somewhat different ways of attacking the problem do not talk to one another. In fact, it goes so far as to be hostile. Mm-hmm. So, for example, I have had one of my most successful papers, in the sense of the number of citations, one of the referee reports said that this should not be published because it's only theory. Enough said. And luckily in that instance, the editor was smart enough to ignore that. But I think this is quite a serious problem in the biological and social sciences. The other thing to do with data, I've forgotten, I wrote that essay actually, Big Data Needs Big Theory, was that I used to think that, and it's to some extent still true, that one of the things that limits progress is data. That has changed because now we're creating huge amounts of data and there's much more focus on getting data, and data is the fuel of science, basically. I mean, good science needs good data. But what has happened, this thing has become sort of a tidal wave. The data itself becomes what science is, and it's sort of with no conceptual framework to organize it, and therefore to make something that is crucial in science, and that is to be predictive. And again, I see that whereas we've had this marvelous advance, and now aided by AI and machine learning with all its faults, but it's being hindered because people seem to think that just having the data is enough to actually, quote, understand.
I mean, I did want to, just pushing on this a bit, because and I think many of you share this view with me, is I consider the conjunction of excessive amounts of data and computational power inimical to the progress of science. And,
yes,
right,
yes.
I just want to ask all of you about that, because it actually, in some sense, short-circuits
Yes.
the need to think, right? And in the end, science, like the arts, is a way of making sense of being in the world. So I'm just curious, anyone can address this, but what about the negative sides of having all of this data and compute power? I don't know if you've thought.
So I have recently gotten obsessed with the science of measurement for this reason, because it's interesting, because I'm reading papers now where it's exactly this, where there's a ton of data, and they're like, now we just have enough data that we can do science on top of the data, and so the machine learning algorithms can just do all the science for us on the data. And I just think about the history of physics in particular, which was so deeply tied to our theoretical abstractions being embedded in measurements that could be taken with new technologies, like what you're describing, and that it's actually the integration of the new kinds of experiments and measurement that allow us to build new abstractions, that allow us to have new ideas, that allow us to build new technologies. And if we're just going on data, we're just basically decoupling all of that narrative from actual physical reality. And I don't want to live in that future. It's like a very scary place to me. It's not real. And I don't see any possibility for these algorithms to be going in the lab and inventing new measurement techniques like we had to do for temperature and things like that before we had theories of thermodynamics. So it's like if you look at the history of physics, every single major advance in physics was driven by some experiment someone did in the lab with some measurement they did really precisely, or some new measurement they took and interpreted in a new way. And that's not built in our data.
Anyone else want to address that?
And I think in my field, you can be misled. I mean, large language models and machine learning in general can be misled by certain patterns in the data that aren't real or aren't predictive in a deep way of future data. So you have to be very careful about, well, we think we're seeing this, but now let's, pre-register our hypothesis and test it in a new data set and see if we are really seeing what we think we're seeing, or whether the data is misleading us in some way because of it's doing what we think it's doing it this way, but it's actually using a very simple rule that we can't see. So we have to be very, very careful.
It's also good at predicting the past, sorry. No, just one quick thing. It's good at predicting the past, I think, but not the future. That's all I wanted to say.
Well, I'm just going to add, I mean, there is a culture in Silicon Valley that there's no need for theory. I mean, that, you know, I'm sort of repeating what I said, the data, especially now with AI, is it. You don't have to do any more. You don't need Newton's laws or quantum mechanics and relativity and so forth. And that's extremely challenging. I think it's challenging philosophically, and to my mind, it's obviously wrong.
Mm-hmm. Well, it's interesting. There, you know, we now have these language models like ChatGPT that have been trained on huge amounts of human-generated text and have somehow learned all of the rules of language. You know, they can really sound like people using language. And we didn't need to program them with grammar or any kind of rules. They just learned it on their own. And in fact, there's a famous story that Microsoft that, you know, they were building these machine translation machines to translate between languages, and they said every time we fired a linguist, the translation machine got better because the data was better than the rules or the theory. And I think that, as you say, Silicon Valley is kind of taking that to an extreme. Yes, it's saying we don't need any theory anymore. We'll just throw our data at it and our machines will figure it out. But it's that, even if that works, as Sarah said, that's not a world I want to live in, because it's kind of saying a goal of science is no longer understanding.
That's right, yeah.
And for all of us, I think that was exactly why we went into science.
Yes.
Yeah, I think that just to communicate to folks in this room, there's almost no concept that I haven't heard mentioned, you know, no more than the concept of understanding and the concept of intelligibility and the concept of meaning. So there is this sort of, I think, naive sense that the purpose is utility. And prediction is very important, of course, but so is understanding. And in that respect, science is not the way it's portrayed, I think, very often, or the way it's taught.
But science, I mean, good science is an iterative process between prediction, understanding, theory, hypothesis, speculation, and phenomenology. You know, I mean, that's what it is. It should be all of the above. And the AI, I mean, the sort of big data AI thing tries to short circuit that by just I mean, it's that same thing of, in a certain sense, you know, correlation being causality. I mean, it's the same issue kind of thing. So you need understanding, ultimately, in order to break that and go to a much deeper level.
So let me just continue with this, because that's something that I did want to talk about. So we live in by now, the ambient culture is computational. Many of us on this stage grew up without the internet. I'm sure that's true for many of you. And that's no longer true, right? So, and the science at SFI could not have existed without computation. We are a computationally enabled institute. And I just want to give a list and just see how everyone feels about this. So early on at SFI, so the early days of you know, mini computers, and think about, you know, microcomputers, things like the Apple II or the Sun or the Next workstations. And we were doing simulations of things like cellular automata, probably some on the, you know, but that's Babbage, but, you know. And Melanie was actually a pioneer in one of these fields called adaptive computation, the use of genetic algorithms, optimizing inspired by evolution. Then we got into agent-based models, and you've probably heard about that a lot at talks here, which are coming back. And in fact, Doan, who recently spoke here, is a huge advocate of the new wave of agent-based models. And now we have machine learning. So we've gone through these epochs of different computational frameworks, some of which died, some of which are coming back to life. I'm just curious. So there's a negative side, as we've discussed now, but what's the positive side of new paradigms in computation for complexity science? Anybody? Melanie, it's probably much more you.
Yeah, let's see. Well, as you say, you know, computation has allowed us to simulate the world. There used to be two ways you could do science. You could do theory and you could do experiments. But now computation opens up a third way, which is now you can do your experiments, test out your theories on computers instead of having to go out in the real world. And you can actually do quite a lot of really interesting work that way. And in fact, most of the work, as you say, at SFI has been that kind of paradigm. And that's just opened up, a huge a huge way of kind of gaining insights. I remember my former co-advisor as PhD, John Holland, who was an early member of the Santa Fe Institute, used to talk about the analogy of a flight simulator. Flight simulator would give you sort of the ability to practice flying and to hone your intuitions about what to do in different situations. And for him, computer simulations were like flight simulators. And I think that's been incredibly positive. We couldn't work without it. Mm-hmm. But I'll just say one other thing, which is, it's not just using computers, but also the theory of computation itself. Mm-hmm. Understanding what can be computed, how fast something can be computed in principle, how much memory you need to compute something, turns out to be actually quite relevant for a lot of the problems in complexity, surprisingly, I think. And that's been also a revelation.
Actually, so that's something for you a bit, Sarah. So I think we share, we disagree on a few things, but in terms of the origin of life, this computational, informational perspective, and you've been working on this big, new, grand theory based on assembly theory, that is a kind of computational, combinatorial theory. Do you want to talk about that just a little?
Sure. Mm-hmm. So the conjecture is that life is the only mechanism the universe has for constructing complex objects, which is very fitting, being at SFI. And then there is sort of a procedure that's embedded in the physical construction of an object that talks about a minimal way of recursively building a structure from simpler building blocks. So we talk about it in chemistry, and we have ways of measuring this in chemistry, which is why I'm obsessed with measurement, because if you want a theory of physics, you have to have a measurement. But you can think about elements and how you can put them together, making bonds to make molecules, but you can also use Lego. So if you wanted to make something like Lego Hogwarts, for example, you can smash the castle, and then you have to ask questions about, how easy or hard is it to build an object that complex? And you don't think it would happen spontaneously by shaking the Lego pieces. There has to be some kind of information processing system that has some prior selection or informational constraints to make that particular object. And so we have lots of ways of talking about that, but it's really interesting because I started my career thinking about information and computation as being pretty fundamental to life, but in trying to construct a theory of physics that accommodates that, I feel like I'm living in this sort of post-computational paradigm space, because I think the sort of ontology of computation is not sufficient to actually understand what's going on, because it's very observer dependent. And very description dependent. And what I like about thinking about measurements and what you actually go and physically observe is it's no longer dependent on our modes of description, which is a very computational way of describing the world. And what the universe actually embeds is the sort of quote unquote algorithms it uses to construct physical reality. And so that sort of transition for me has been really interesting. It's a little like I feel like right now the way that we talk about computation, it's the end. It's like the final description of nature. We've gotten there. And I think it's very human-centric. It's very centered on our cognitive architecture and how we interface with the world and how we've chosen to embed that in our technology. And I think that what the sort of transitions we're seeing, the existential crises we're having with AI, is we're actually allowing ourselves to see what we look like from the outside in some projections in the physical world. And I think this is going to mediate descriptions that are beyond computation. And this is, to me, the sort of most interesting thing about living now. And I guess the final part that I think is also really cool, which was pointed out to me by a philosopher, Ben Bratton, who's a philosopher of technology, is that many periods in human history, our philosophy has been far ahead of our technology, but we happen to be living in a period where our philosophy has not caught up with it. And I think this is a really profound part of existing now, and I find it really exciting. Like, I think the fact that we're so existentially challenged in our understanding is very exciting about living now.
Yeah, that's certainly positive.
Can I riff on that?
Yeah.
So, I love what you just said about there are limitations of how we as human beings can process the world and the kinds of theories that we can come up with. And in some ways, I think, going back to maybe the first question on the rate limiting, I don't know if that was the first question, but a failure of imagination is, I think, really with us now. And it's, there's this great, in psychology, this thing called the end of history illusion, which is if you ask anybody, how much have you changed in the last 10 years, and how much do you think you're going to change in the next 10 years? People will invariably say, I've changed a lot in the last 10 years. It was just a roller coaster, a lot of personal growth, but now I get it. I get who I am, and it's going to be pretty steady state from here on out. And what's interesting is you can ask people in their 20s, 30s, 40s, 80s, everybody has the same answer. Whoa, you know, the last 10 years, wow. But now I get it. And I think in all of our fields, the same thing happens where we say, oof, the Victorians, right, they were drilling holes in the skull to let the demons out, they didn't understand migraines or whatever. Like, now we have neuroimaging, we understand how these things work, and now it's just sort of crossing the T's and dotting the I's going forward. And there's this sense that we're at the end of history, like we've sort of figured a lot of it out, and it's interesting because it's as if the failure to imagine the future, rather than us concluding, oh, that's on me, I don't know how to think about the future. We just assume that if the information is missing, and if I can't articulate the information, then it must be small, or it must not exist, right? That it's as if the limits are on the world rather than the limits are on us. And I think what I love about SFI is this willingness to sit in uncertainty and not knowing. And I think there's a great Feynman quote about this, about I would rather not know, I'd rather sit in uncertainty than have answers that are wrong, right? I'd much rather just, even if I can't really imagine, that I can imagine that it's going to change, even if I can't imagine how exactly it's going to change, and being open to that possibility space.
Yeah, I did want to, I mean, just on this question, I mean, yesterday I spoke about Hamilton's principle, this principle of least action or stationary action, which is, and I think it's fair to say that now, to both of the points you're making, we're so much more algorithmically oriented. Someone like Stephen Wolfram would call rule-based. We're much more interested in rule-based systems than these simple, low-dimensional optimizations for various reasons. And so as to Melanie's point, it's not just the use of computers. We actually think of the complex world as intrinsically a computational process, above and beyond a physical process. So anyway, just...
But having said that, presumably we're looking for, or asking, are there underlying that? Because computation, putting it in that language, sort of means there's lots of different things and all different ways of doing things and so on, and that's the way the world looks to us. But underlying it, maybe, there are universal principles and universal invariants, and in fact, that underlying the extraordinary complexity of the world around us is simplicity at some level that is very hard to see sometimes. And of course, one of the most amazing things about the universe, which intrigues me, is that what's going on here, almost what's going on literally here, is more complex than the fucking universe itself, which is simple.
Yes.
Because I could write in the corner up there the equations that tell me about the way the universe evolved, black holes, formation of galaxies, and so on. Well, if I can write it up there, that's pretty simple. But trying to describe what's going on in this room is infinite numbers of equations. If you wanted to put it in that.
And I think exactly this, you've just made the point for me actually, that something about the complex world doesn't seem, except in the case of extreme averaging or coarse graining, to yield to these simple frameworks, and we need to move, it seems, to these more contingent generalities, and it's a challenge, right? Is that just a lack of imagination, or is it something intrinsic to the nature of complex reality?
I think that we talk about it wrong, though, because the universe, as you just described it, is an emergent property of our description of it. It's not the thing out there, right?
Well, that's a debatable point.
Yeah, no, I mean, it is a thing out there, right? But, like, I
mean, there is something out there, by the way.
No, I'm not disagreeing with that, but I think the fact that, like, it gets to David's point, like, the fact that you could describe it simply is because you're now looking at this coarse-grained description of an emergent property of all of these things, and we think of the universe as being at the bottom, but really, like, the thing we're talking about as the whole scope of everything is, like, the aggregate of all the things that exist, which, you know, like, you could maybe talk about at a really simple level once you coarse-grain over everything, and then you get some boring equation that describes it all.
That's the most interesting part.
Thank you. Sarah and I agree on this. Jeffrey, you're wrong. So let's move on to the next question. This is my prerogative. I mean, this is my job. So on this
underlying it all, by the way, is Hamilton's principle.
No, I mean, so let me just shift a bit. I want to shift to, I mean, what we're sort of trying to do here, actually, I think, and that is communicate.
Oh, I got to interrupt you, because by the way, it goes to what you said. Thinking that it is so complex and you have to all this stuff is what is hindering progress. You have to have that coarse-grained idea that underlying it are universalities, simplicities, and generalities. Otherwise, what the hell is the point of doing science?
Yeah. Well, that goes back to my thing. You have to believe you can solve the problem, which means you have to be able to describe it.
Yeah, but if you don't try, you're not going to, you know. Okay.
This, by the way, is everyday conversation at SFI. This discussion, this argument. And so it's actually quite an honest argument to be having. So I want to talk about communicating science. And I think, do I see George here, or George Johnson? I don't know. We've always had great science communicators living in Santa Fe. And most of this panel has also endeavored to write more accessible science books and works, and appeared on TV shows or podcasts and so on. And I'm not sure we're making a dent. I feel as if we're living in a world it's either very, very bimodal in its attitude towards science and evidence, or we're just not doing a very good job at all. And I just want to talk about your attitudes towards communicating science in the pursuit of a science-literate democratic society that can ward off totalitarian nonsense. And so I don't know, what is your sense of responsibility in terms of communicating these ideas?
Well, I think it's a huge responsibility. In fact, I think it's one of our jobs. And it's very frustrating, actually. And in fact, with this series, you know, the public lectures of the Santa Fe Institute is one of the great examples of trying to do it. You know, and presumably the fact that we get, you know, a good-sized audience means that at least in a local level we're succeeding. But the bigger question, of course, is, you know, the populace out there and the huge ignorance and misunderstanding of science, and in particular of the scientific method and what science means, and you know, the way it's been abused and misused politically and socially is, of course, one of the major issues that is only going to get worse because, ironically, that science produced the internet and social media. I mean, it's kind of, we sort of undermined ourselves unwittingly by doing the science that allowed all that to develop. Because what it's meant is, you know, it's almost a platitude. It means that people can just listen to what they want to hear. And the big frustration, I think, for us, those of us that try to make an effort to reach out into the general public, is that you know, you're only getting a limited audience. I will say, you know, I give quite a lot of both sort of public lectures and giving talks at non-scientific meetings, particularly those of the of sort of business community and so forth. And I have to say, I get very good reception, always get tremendous reception, but I feel I'm comic relief. Mm-hmm. You know, you should have a scientist, you know, among all the financiers and AI people and all the rest, which I don't consider scientists, by the way. But and that's an issue, and I don't know how to address it. It's extremely frustrating. But having said that, I think it's part of our job is to reach out and to try to explain and try to articulate not only what science is, the power of science, what it's done, and its limitations.
Yeah, I mean, I feel like it's a big part of my job. It's been a little bit frustrating. Now at SFI, it's great, but when I was at the university, it's not something that you got rewarded for or incentivized to do. And in fact, sometimes you would get punished for it because it's taking time away from your real job, which is, you know, getting more papers published and more students to graduate with their PhDs. But I've always found it to not just be sort of a one-way street of me explaining science, but when I'm writing about my work or when other people's work, it's actually helping me to think and to better understand what I'm doing. Teaching does that, writing does that. It's very beneficial. But as you say, that, you know, we're in a world where, you know, we have a crisis of attention. There's so many things out there, and so few people are actually, you know, reading about science. There's so much out there. Maybe what we should be doing is moving up to the new media that people are actually paying attention to. We should be making TikTok videos or whatever. I don't know exactly what. But,
that's terrifying.
But I do feel like it is hard to reach people. And it's also hard to, you know, we were talking about living with uncertainty. You know, it's better to live with uncertainty than to have the wrong answer. People don't want to hear that from scientists. Mm-hmm. They don't want to hear that things are uncertain, that we don't know the answer. That makes them in some way distrust science, which I find, you know, kind of disturbing. But that's what we saw during the COVID pandemic quite a bit, because we were not, you know, scientists didn't have the answers. And people said, well, you said wear masks, and then you said don't wear masks, and then you said wear masks, and we, you know, you guys don't know anything. You have nothing to say to us. And it's hard to know how to respond to that and how to kind of better communicate what science can and can't do.
I like to fail in public. I mean that very sincerely. I would never consider myself a science communicator, and I don't, like, I love science communication, but I think, book. I know I did, but it's, but my goals with it are a little bit different. It's not to, like, I don't view myself when I'm doing these kind of things to tell people what we know. Like, I'm much more interested in what we don't know, and I think one of the reasons that, you know, there's sort of a dichotomy between the scientific elite or academic elite and the public is because the established narrative is these people are experts and these people aren't. And I think what really, like, for me, there are just some questions no one knows the answer to. And there's a lot of them, to the points that we've been raising. And what I like to try to do is open a dialogue about the things we don't know. And I think that's much more humanizing and it invites people in, because the structure of our knowledge is constantly changing, and I think a lot of us don't understand why it's changing because we're not trained in science. And even as an undergrad, like, you just learn science works this way, and like the second law of thermodynamics is law, like you cannot disobey that. And I don't even think I agree with that principle anymore, but like I went through a whole long chain of thinking to like be able to question that. It took me a long time to get there because of the way I was taught science. And this is the existential crisis people have when they get to grad school, is like, oh my God, you're forcing me to think. I have to come up with a new idea. I can't accept the things I'm taught. Like, what? And so my approach to communication is, we're working on really hard problems. If these problems get solved, it's transformative knowledge for everyone. And that needs to be an open dialogue with everyone. We're building narratives for the future, and that needs to be something that we're discussing together. And so for me, it's not like a one-way communication. I actually get ideas by talking about things publicly. I like to talk about the thing I'm working on now, and I don't understand it. And then, getting the feedback of how different people interact with it helps me structure my thinking. But I think, it's hard to do that, but I think if we had more of that, it would be really great, because it's not that people don't like to think. I think everyone likes to think, but I think we recognize some people don't know how to think. And I think at least recognizing that those of us on the edge also sometimes don't know how to think about problems allows them to understand when we do have failures and when we make mistakes. And I think we just need to be more public about that. We need to be willing to talk about things we don't know, to your point. And so I am really pushing new ideas, and if I make a big deal about them and they totally fail, that's actually like a brilliant enterprise. If they succeed, great, I'm really excited, but I hope they do. But also, like, if the whole thing fails, it's like somebody was trying and they were trying to do it honestly in public.
I think my students really respond. They come in, so I teach intro psych, and it's usually like freshmen, the first class they're in college, and they come in and they just like, I just want to know what the answers are. Just tell me what the answers are, write them down, and regurgitate them on the test, and that's what learning is. And they get a little bit discombobulated by me saying, no one knows. Why do we dream? What is consciousness? Like, there are these big questions, and we don't know. Like, we can tell you how we've been trying to figure it out, but we still don't really know. And let's think about this together. And you can see the evolution from them being really unsettled by that. I think in some ways because of the 24-hour news cycle, where coffee gives you cancer. No, wait, it doesn't. It's like these sort of answers. But then when you say, no, science is a big tent, come in, we'll talk about it, we'll try to devise, you've got great ideas, let's devise an experiment that you might be able to crack this open. And when it becomes that kind of discussion, then they sort of see a place for themselves in this scientific enterprise, and that's really rewarding, that becomes open to them. And I wish that was more, I don't know if that message was sort of more out there, that we're in this together, we're trying to figure this out, and we don't have pat answers, and that's okay.
Fantastic. Well, on that note, let's open it up to communication with this group. Join me in thanking the panel for this contribution. So we'll take some questions. If you've never asked a question here before, it tends to be the same people who ask the questions, and we love you. But it would be wonderful if other people who had never asked a question before would, and that would be much appreciated.
Hi, thanks for this. I work on antitrust and tech policy, and you all got into the political economy of AI a little bit, but I was hoping you could expand on it, and maybe particularly from a sort of complex systems perspective that looks at how markets shape things, how homogeneity impacts things, anything along those lines.
She wants how the political economy and complexity in markets.
I didn't understand the question.
I didn't understand it.
Was there a question or was there a comment?
That was a question.
No, it was a question, it's complex, but I didn't understand what the first part was.
So you all got into the small conversation about the political economy of AI, the corporations that created it, or current version of it, the incentives behind that, how it shapes AI, the ideas behind it. But Jeff, you look at markets. Others, I think, look at the impact of homogeneity, where innovation comes from. So right now we have a handful of companies dictated by Wall Street profits, and that's created a lot of the things that you were talking about. So I just wanted to hear further reflection on that.
Well, I can say something. I mean, right now, I think you're asking about AI in particular, right? That AI is controlled by a small number of very wealthy companies, and this is shaping the field in a way that would be very different if AI was, say, being created in universities or in government labs. Instead of becoming a science, as Jeffrey said, it's really dominated by engineering, trying to build systems that will make money for companies. And I think that's quite dangerous for the world. In my opinion, I think that that's going to cause, first of all, it creates misinformation, I think, about where AI really is. There's a lot of hype out there because hype is good for selling products. And it also means that these big companies have a lot of control over our lives, over our data, over our things that we do on the internet are being used to train these systems. And it's, it's something that the government doesn't really know how to regulate because policy has a hard time keeping up with technology. You said philosophy has a hard time keeping up, but the legal system and the government regulation has an even harder time keeping up with the speed of technology. So I think it's unfortunate, and it's going to continue to evolve that way because that's the way our economy works.
I mean, one way to have your cake and eat it, to allow for productive market forces and for science, is open source. And we've had lots of debates about open sourcing this code base. And so in that way, you do get to participate in the progress, but you're not necessarily entirely handicapping the market if you believe that that plays an important role. So it's a very complicated problem, but open source is clearly one very important element.
But the problem is, open source is really, and transparency is important, but the most successful big AI companies are pushing against open source. They're saying it's too dangerous because AI is going to be so dangerous.
Right.
But really, the lack of transparency, I think, is what's dangerous.
Mm-hmm. Yeah, definitely.
I have a question for, I guess, mostly for Sarah, but anybody else's opinions would be very interesting to hear as well. In the last several months, that's when I started discovering Sarah's work about what life is and the origin of life and how to define life, and it's kind of gotten me more confused than ever.
Good. You can join us. We're all confused.
But the one question I wondered, if I had to think of one question about it, is what are your thoughts about how the universe has created entities like us who are self-aware, conscious and self-aware? Mm-hmm. Just wonder what your thoughts are about that.
The short answer. I think that I have no soundbite for that one. But I guess my quick answer is, God, this is a hard one. I think the universe is constructing itself. Like, I don't think there's descriptions that come outside of it. And then it's interesting to me that things like us emerge over billions of years on planets that end up trying to build effective descriptions. And I think that's a highly non-trivial feature. And I think it's very deeply embedded in the structure of physical reality, and I think we need to take it seriously as a fundamental property of our universe. And in what ways that looks, I think we don't know yet. And I think, you know, some of the things that everyone here is talking about and what we're trying to do with building a theory of life are starting to scratch the surface of what that looks like. But, you know, it took us many centuries of science to even get to the point that we could look at science as something of objective study. It's actually interesting, the recursion. It's like science is supposed to study the universe objectively, but we don't know objectively what science is. So I'm interested fundamentally in new explanations. Any new explanation to me is good because it gets us outside of our box.
Right.
Yeah, go for it.
I have a sort of non-scientific response to your question. It's not an answer at all, but maybe a comment. And that is, you know, I suppose many of us got into science, sort of the most fundamental level, somehow not just to understand things and the wonder of, you know, the stars at night, but, you know, what's the meaning of life? You know, what's the point? Because, you know, when you think about it, when you wake up at 4 o'clock in the morning worried about things, it all seems so pointless. The whole thing is sort of pointless. I mean, what is the point? And, you know, why are we here? What are we doing? We're going to live a life of, you know, 70, hopefully more, and that's it. But what was the point of it? To have more children than to live 70, and so on? That's what sort of biology is. So here's my thought, which is almost certainly, you know, others have had it, and that is that the universe needed to evolve consciousness so that it would know itself. It's a little bit what she's saying, but in a different language. An electron does not know it's an electron unless we're here. We're the ones that tell it's an electron. But we also are the ones that give meaning to all those stars that are lifeless. Maybe some have life on them, probably do. But without us doing and having these kinds of conversations, doing the kinds of thinking and science and the great thinkers of the past are really grappling with giving consciousness to the universe so that it understands itself.
I'd like to take you all out for dinner.
Yeah, I sort of a corollary. I think you already answered my question, but is consciousness a quantum phenomenon?
Jeffrey.
Well, first, the preface. This goes a little bit to last night's lecture of David's and the level structure. You know, and it was encapsulated, and if you were here last night, in Phil Anderson's comments, an essay about the fact that these levels in science exist. And so, you know, which means that, naively at least, the fact that there are quarks and gluons and protons and so on is not relevant, mostly, to life itself. So therefore, not relevant to consciousness. That may not be true. I mean, there's leakage, as you, in fact, even indicated. But, you know, the consciousness seems to be at a scale above quantum. Now, I do believe Penrose believes that it is a quantum phenomenon. I don't understand it, frankly. You know, but I would say that most scientists that know physics, that's the first point, and understand this whole question of level separation, would say that quantum mechanics, in the leading order of thinking about it, has no immediate effect in terms of the origins of consciousness. Of course it does, as you dig down, obviously, because without quantum phenomena, we wouldn't have quarks and gluons and therefore protons and neutrons and atoms and nuclei and so on, and therefore complex molecules and therefore life. So there is this connection, but they decouple.
Yeah.
So I would say it is not from that. So it depends a little bit on what sort of philosophical view you take.
I just
Which was encapsulated in David's talk, actually.
Yeah. So your point was about like the scientific retort to that, but I just want to make two comments that I notice when people bring up the association of those that are more related to the sociality of science, which is oftentimes if we don't understand two things, we equate them as being equivalent. So people don't understand quantum mechanics and they don't understand consciousness. So they think they're the same thing, and that becomes an effective. So this is a real phenomena. But also, if you were doing the hard work of really trying to understand those both at the same time, as we have done in the history of science, trying to unify phenomena that seem really different, the effective descriptions you come up with never look like the things you're originally talking about. So if quantum mechanics and consciousness were the same, you would actually have a theory that explained both that was much deeper than either. Yes. And it would be neither of those theories. So this is a very sort of superficial association people are making because it's easy, and it's lazy to me. They don't want to do the hard work of actually asking the question.
Yeah.
Here.
Yeah.
Good to go. First of all, I want to congratulate the five of you, because I've sat here and I've observed you. And what I've noticed is that you have moved through the peaks of academia and specializations in whatever your science may be. And you guys now waver at the point between what I would say is academic understanding of life, and then transition over to the relational understanding of you with life in the universe itself. And you're in a rare spot, and I know you see or state that there's difficulty in communicating that back with the public. But I wouldn't fret too much, because when I watch you do this, your ideas are passing through to the right people, and it's not about changing millions of minds, but frankly one mind that can act upon it. And to take that a step further, you talked about the fundamental drawbacks or a framework that's been missing in terms of how we would define intelligence, or what is the rate-limiting factor for humans evolving. And the way I see this is that we've taken so much time focusing on knowledge which is explicit, knowledge that's on the outside, and we've applied that into algorithms to give us essentially a mirror of ourselves. But the one thing that's been missed is, say for instance, the studies which you do with people in the MRIs. Knowledge or intelligence is actually relational between human beings, just as much as there's intelligence in relation between us and nature. And I think you all approach it at different angles, but you're all talking about the same thing. And you're right, there needs to be a union of minds and thought of different specialities, but recognizing that you need to focus on your relationship with that nature itself. And that could be searching for life and existence out there. But the things we haven't studied well are the things that are unspoken, tacit knowledge, things that are implicit for human beings. Those are the things that haven't gone into algorithms. But those are the richest things that happen here for us in community, or even being a part of these groups. And I think I'll stop there with my statement. So thank you very much.
Thank you. Is I don't know, what's the timing?
I think we have time. Sorry, hi, I have a mic. We have time for two more.
Two more questions.
Yeah, so I have a question here, and Melissa can bring, there we go.
Hi, I got super excited hearing about your work in this relational neuroscience and the new tools that you're using to gather emergent ideas, and might be difficult to predict, but I wonder what your thoughts are about how this work will impact forthcoming work in artificial intelligence and that sort of technology.
I hope it does. I think when we better understand how human minds connect to each other and do their thinking in this collective space, and that is what it means to be intelligent as human beings, that will translate, I don't know, for better or worse, I think it will make machines more intelligent if they also just potentially network with other machines. And I mean, one thing that we're learning is, in fact, Scott Page, who's also a SFI external faculty member, has written a book, I think, called The Diversity Bonus, that actually conversations with people who are not exactly like us but have different perspectives are really important to advancing our understanding about things, like the triangulating on an idea, not just hunkering down in an echo chamber, is really important for our intelligence. I can imagine that creating a sort of a networked artificial intelligence where you're getting diverse inputs rather than sort of homogenizing a kind of a normative intelligence would be great. But you know more about this than I do.
Well, I mean, no one knows because people haven't really done that yet. But I agree with you. Right now, everybody who's working in AI is training their systems on the same data and trying to create a system that in and of itself is going to be the intelligence. But I think everyone that I know in cognitive science would say that an individual human, apart from everybody else, is not intelligent. You only have intelligence in the context of other people. And that's, at least in our species, the social part is so key that it's amazing that people in AI aren't paying more attention to it.
I mean, I would add just one modulation to that, which is the point made by one of our colleagues, Alison Gopnik, at Berkeley.
Who is our next lecture on October 15th, please.
And that is that, was that you, Caitlin?
That was me, Caitlin.
No, what was that?
Alison Gopnik is our next lecturer, October 15th.
Oh yeah, Alison's giving a talk next.
Oh, she's talking next?
She's next, October 15th.
Oh, good.
That
So
should be
come to that
fabulous,
talk. Well,
yeah.
Alison has made the point that an AI is a collective intelligence. And AI is already the aggregate knowledge of huge populations of humans. It's more like a library than an individual. So I think there's a sense in which it might not, that might not be correct.
But it's very different than what she's saying, what Melanie is saying, because that's somehow an averaging agglomeration, but
Yes.
it's not dialogue.
It's not dialogue.
Yeah,
And
it's not
the
dialogue.
crucial thing about, there's no such thing as a single human being. It doesn't exist. I mean, we only exist in community with others. And that community means interaction, dialogue, and continuous change. And that is not what's going to be happening. In AI, in fact, it's sort of obvious in a way, naively, that if AI just keeps training on the same data and then trains on itself, it's going to just reach some, uninteresting asymptotic state, which, whereas the fantastic thing about human beings is we're sitting around with all this bullshit going on, and we're building on each other. There's continuous positive feedback, and ideas are generated time and time again, continuously, all of which are useless, except once in a while, out comes the theory of relativity, or Amazon.
No.
That's what's
Maybe not. Was there
But AI will never do that.
one more?
There's one more
yeah.
question all the way over there.
Thank you. I guess I have a more simple question, and we're talking about communication and
If you
intelligence.
speak just a
Speak
little
up.
closer to the mic.
Oh, sure.
Great, thank you.
When we're talking about intelligence and communication and technology, and I guess I have two questions. One is how you feel the innovation of technology has affected the communication between individuals. Is it a positive? Is there something maybe we're doing less communication face-to-face and more with our cell phones and texting and such like that? And the other is the correlation between the science or philosophy and art. And what artists do when they get together and they discuss and they look at the world and how they want to explore that.
I can take the first one, that our technology, right now we're in a period of time, I think, where technology is being disruptive of our social connection more than in a positive light. I will say, during COVID, I was very grateful we had Zoom and FaceTime, because it gave us something. But for those of you who did, cocktail hour on Zoom, I mean, how many of those did you do before it just felt like another meeting with a glass of wine? It's not the same as meeting your friends down at the pub for a night of spontaneous conversation. And the fact that we're on our phones all the time, especially for kids, I think COVID was extremely disruptive. In fact, we have data for the last 10 years, and from 2014 to 2020, we have studied people's social networks. And they were always about the same sort of size and the same kind of configuration, and then COVID happened, and just everything sort of fell off a cliff, and people just sort of hunkered down with just the people that were sort of close to them, and that made sense because there were lockdowns and there was distancing, but it's never come back. We're like, we're 4 years out or whatever now. And I think COVID actually fundamentally changed intergenerational cultural norms of socializing, just sort of got wiped out and now have to sort of come back up. And I just saw that Amazon is making all of their employees be in person again 5 days a week. I think because they recognize, I'm not saying that's the right approach, but they recognize something was lost. And what was lost was these spontaneous conversations we'd have at the water cooler, in the mailroom, or what have you. Those just fell away, and those were moments where we could meet someone that maybe we hadn't really gotten to know yet, or had a different opinion. Or so I think we can't outsource our social world to these devices. I think that's a mistake. I think there's still something extremely special about this very precise, evolved technology that is face-to-face communication that we need to, that's precious and should be cherished.
All right. On that note, I will say just quickly on the art question, I do want to just quickly relate to that, because of course we've had many artists and writers at SFI, it's a minority, but there are important differences. I mean, the similarities are we're trying to understand, represent, encode reality, discover our place in it. That's shared. But there's a very interesting difference, and talking to my artist friends, science really wants total consensus, right? Unfortunately. You would like your idea to be the idea that's accepted by everybody. Most artists I know want to annoy other people, or a certain number of other people, and offense and subversion is really core. It's a part of science in order to arrive at greater consensus. Whereas I think the idea of challenging authority is much more profound in the arts than in science, even though we both believe in that.
If I understood the first part of your question was about the disruption due to technology, positive and negative. And of course, that's true. All new technology has, of course, both sides. But, and we often think that, the changes that are taking place now are bigger than has ever happened before. And, of course, that's almost certainly not true. I mean, after all, the Industrial Revolution was probably the most disruptive phenomenon that's happened socioeconomically on the planet in terms of human beings. We went from being rural agronomists as people, primarily, overwhelmingly on the planet, to everybody now living in cities, all because of all because of the discovery of coal, the use of steam, and the exploitation of those, and concomitantly, of course, the, discovery of free markets, entrepreneurship, and so on. And that all happened pretty much at the same time, the beginnings of that. And that's all technology in one form or another. And, it completely changed everything. It created enormous slums, people were in servitude, and so forth. Little boys and girls were going down mines and so on, all that. But here we are, we're the product of that. So I don't think there's an easy answer to any of this. I think it's, I once had an idea that it would, that's like that, it's sort of like a question about religion. How, the effect of religion, how positive has it been and how negative? Because if you read, the Bible, it sounds fantastic. and yet, you know, the horrors that have come from religion and are going on as we speak. And I've often thought it would be a sort of fantasy exercise to have a big ledger book where you put numbers to, you know, the Bach St. Matthew Passion, put some amount of money to it, great Gothic cathedral, all inspired by religion. And then, you know, the various wars that have been fought in terms of religion, put negative. And you add up, and you make this league table of religions as to who has been most positive and who has been most negative. And my guess is, anecdotally, that most religions have ended up on the negative side. And I'll leave it to you to determine which one has been least negative.
On that note, thank you very much, everybody. Thank you very much.